Hi, I'm Giacalone, Principal CTO Architect at Ciena. If you're interested in AI infrastructure, you've probably heard of scale up and scale out. But what are they and why do they exist? AI training involves huge mathematical models and large amounts of data. To fit these into GPU memory while minimizing training time, the model and data are split across sets of GPUs. But during training, the model needs to be iteratively consolidated, and that imposes various traffic flows on the network, each of which have different performance requirements, but all of which are intolerant to jitter and loss. Congestion or packet drops can cause training corruption, stalls, or restarts. These training issues are costly and time-consuming, and so we place training flows onto dedicated AI networks, scale up and scale out. Scale up and scale out exist in AI clusters to protect training flows with high capacity, low latency, lossless network connectivity. Scale up and scale out have different performance and size characteristics, and they use different technologies. Scale up is the smaller but high capacity AI network. For example, in NVIDIA's GB200 design, it provides 14.4 T of capacity to each of 72 GPUs in a single rack. Larger, faster scale-up designs will be coming soon, and in some cases have already been done. In NVIDIA's architecture, scale-up uses the bookended or proprietary NVLink protocol, which provides integrated congestion and buffer management at high speed. However, new standards such as UALink and ESUN are being launched to open the scale-up ecosystem. Scale-out, on the other hand, is the larger but slower dedicated AI network. Scale-out can support hundreds of thousands of GPUs in a single campus, but at Ethernet speeds. Most scale-out networks run the RDMA over Converged Ethernet or RoCE v2 protocol, and that encapsulates the InfiniBand transport layer in IP and Ethernet. To make Ethernet lossless for AI, features like priority flow control and explicit congestion notification are used to mitigate drops. As with scale-up, new standards are evolving, with the most notable being those from the Ultra Ethernet Consortium. In summary, AI models and data are very large, so we split them up across groups of GPUs. However, consolidation is required to build a single, consistent model. That creates various traffic flows, each of which have different performance requirements. And so we map those flows onto our two dedicated AI networks, scale up and scale out, both of which have different AI-focused performance characteristics. Ciena is addressing the scale up and scale out markets with our Nitro and Vesta products. Nitro is our linear ACC redriver that enables ultra-low power interact scale-up with no added latency. Vesta is our co-packaged optical engine with the best density and lowest power in its class. Vesta is also part of the OpenCPX MSA. Contact Ciena to find out more.